Hello everyone, welcome back to this channel. In this video I'm going to be solving this Pure Mathematics paper 1 from October-November 2024. And so let's start. Our first question is saying in the expansion of kx plus 2 over x to the power 4, where k is a positive constant, meaning it's a positive number. K is a positive number, the term independent of x. The term independent of x, that's the term with x to the power 0, right? And we're told that's equal to 150. And it says find the value of k and hence determine the coefficient of x squared in that expansion. So first of all, we need to get the value of k, which is positive, and after that we use that value of k to get the coefficient, the term in x squared, from which we get the coefficient of that expansion. So for us to get the term in x to the power 0, we are going to pick a letter, let's just use n, that we're going to choose from 4, right? So 4, choose n, then we start with the fraction 2 over x, let's just write it as 2x to the power minus 1 to the power n, then our kx to the power 4, this one, minus n, 4 minus n. And this is the general expression that we'll be using. So if we want to get a term in x to the power 0, the powers of x should add up to 0, meaning this minus n for this, and this 4 minus n should be equal to 0. So if we add the powers of x, they should give us 0, right? And this is going to give us the value of n, which is the number that we are going to choose from 4 to give us that term. And this will be minus 2n is equal to minus 4, giving us our n to be 2. So now we know that if we choose 2 from 4 here, we get a term independent of x. So 4, choose 2, then our 2x to the power minus 1 to the power 2, then our k, x 4 minus n, that's 2, right? And this should give us a term independent of x. So 4 choose 2, so 4 choose 2 multiplied by this 2 squared, that's 4, 4, it's giving us 24, and for k it's k squared, right? So if we just want to add in the x squared, this will be x to the power minus 2 and x to the power 2. So these two cancel out. That's why we call this a term independent of x. There is no x in the expression, or in the term. So this is the term we get. And we're told in the question that this is equal to 150. So then we go ahead and say 24k squared is equal to 150. And we divide by 24 on both sides to get our k squared to be 150 divided by 24 to be 25 over 4. Then introducing the square root on both sides, we get our k to be plus or minus root of 25 over 4. But since the question said k is a positive constant, we are only going to take the positive one. So k is the square root of 25 over 4, which is k is equal to 5 over 2. Right? Now we have our value of k, and it says hence determine the coefficient of x squared. So to get the term in x squared now, we first need to get the number that we're going to choose from 4, and for that we're just going to use this because we're saying minus n plus 4 minus n should give us 2 this time, because we're looking for the term with x squared, and the power of x there is 2. So the sum of the powers of x should give us 2 this time around. So minus 2n is equal to 2 minus 4, which is minus 2. N will give us 1 if we divide by minus 2 both sides. So now we know if we say 4 choose 1, we get a term in x squared. So 4 choose 1, then our minus 2x, it's 2 to the power minus x, 2x to the power minus 1. Then we say to the power 1. Then for our k, we are now using 5 over 2. So this will be 5 over 2 to the power 4 minus 1, which is 3. And this automatically is going to give us a term in x squared. So this is k, it should be kx. That's 5 over 2x. So say 4 choose 1 times 2 times 5 over 2 to the power 3. We get 125. And this is x squared. And for the coefficient, we just take this part and the sign, and since it's positive, so the coefficient will be 125. That would be our answer for 4 marks. And for number 2, saying the curve y equals x squared minus a over x is a stationary point at minus 3b. Find the values of the constants a and b. So we know at stationary point dy dx is equal to 0, or the gradient is 0. So we're going to try and get dy dx for this, then we equate it to 0, because we know we're talking about a stationary point here. So for dy dx, we use our differentiation, where we bring down the power of x, then we subtract 1 from the power. So that will be 2x squared minus 1. 2 like x to the power 2 minus 1 to get 2x. Then for this one, since it's minus a x to the power minus 1, bring down the power, we get positive a. It's minus 1 times minus, get positive a x. Then we subtract 1 from the power, we get minus 2. And we're going to say 2x plus a over x squared is 0. This is 0 at stationary point. And since we have the x coordinate of the stationary point, we can just plug it in to get 2 minus 3 plus a over minus 3 squared should give us 0. So this will be minus 6 over plus a over 9 is equal to 0. And a over 9 will be equal to 6, and multiplying by 9 both sides, we get a to be 54. So now for b, since b is the y coordinate, we're just going to rewrite this original equation with the value of a that we just got. So that will be y is equal to x squared minus a. In place of a, we're putting 54 over x, and we're going to substitute the x value. So our y coordinate is the b, so we can write b is equal to, in place of x, we are putting minus 3 squared, then minus 54 over x, which is minus 3, like this. Punching this in, we get 9 plus 54 over 3, which is 27. So our b is 27 and our a is 54. 4 marks. Then number 3, which is a bit long, says the diagram shows the sector of a circle center O, where OB is equal to OC, and they're both equal to 15 centimeters. The size of the angle BOC is 205 pi radians. Points A and D on the lines OB and OC respectively are joined by an arc AD of a circle with center O. I'm sure you can see that on the diagram there. The shaded region is bounded by the arcs AD and BC and by the straight lines AB and DC. And it is given that the area of the shaded region is 209 over 5 pi square centimeters. And it says find the perimeter, which is just the distance right around the shaded region. And says give your answer in terms of pi. So first things first, we have 5 marks to get on this question. If they are saying the area of the shaded region, we know for area of shaded region we say area of shaded, we say area of whole shape minus area of unshaded. Right? So what they're trying to tell us here is if we say area of this whole sector and you subtract area of this little sector, we get the area of the shaded. So for area of a shaded, we're told it's 209 over 5 pi. This is the area of the shaded. And we're going to say is equal to the area of the whole shape, which is the sector. We use half r squared theta. Our r is 15, so we're going to say 15 squared, and our theta is 2 over 5 pi radians. So that's our half, 15 squared, and 2 over 5 pi, like this. And subtracting the area of the unshaded, which is this little sector, with the same angle, 2 over 5 pi radians, but we're not told what the radius is. So let's just call it r. Right? So to get the area of that, we're going to use the same half r squared theta, and that will be half r squared, and our theta is 2 over 5 pi. Now as you can see, this can give us the value of r, which is the radius of the unshaded sector, which we're going to need for the perimeter. Because for the perimeter, we're saying it is the distance right around the shape, right? And for us to get that, we're going to need this length from B to A, this arc length BC, then CD, and arc AD. And for us to get that, we need this radius. So this will give us that. And 209 over 5 pi is equal to 15 squared, 225 divided by 2 times 2 over 5 pi. So it's giving us 45 pi minus 2 over 10 r squared pi. We can just write this as a fifth, like this. So if we factor out pi on the right hand side, we get 209 pi over 5 is equal to 45 minus 1 over 5 r squared. Right? And since we have pi on both sides, we can cancel it out like this. So 209 over 5 should be equal to 45 minus 1 over 5 r squared. And I'm going to take this to the other side first. 1 over 5 r squared should be 45 minus 209 over 5. And to get r squared, I'm just going to multiply everything by 5. and multiplying everything by 5 like that, we get our r squared to be 545 minus 209 over 5, 16, and our r will be square root of 16, so r will be plus or minus 4. But since r is a radius or a length, it cannot be negative, so we take r to be 4. Oops, let me try and make space. So let me try and make space up here. Our r is equal to 4, which is the radius of this. This is 4, meaning our BA is now 15 minus 4, which is 11, which is also equal to our CD. CD is now 11. And to get arc BC, we know arc length is r theta. So our r, which is 15, and our theta 2 over 5 pi, we get 15 2 over 5 pi, we get 6 pi, like this. For this, so we have 6 pi for BC, 6 pi, like that. And for AD, I'm going to say r theta using 4, and our theta to be 2 over 5 pi. So 4 and our 2 over 5 pi, giving us AD to be 8 over 5 pi. So adding these, we get 22 here. So 8 over 5 plus 6, that's 38 over 5 plus 22. So that should be 38 over 5 pi plus 22. And this is in centimeters. And this should be the perimeter of the shaded region. I hope that is clear. And for the first question, we're told, show that the curve with equation x squared minus 3xy minus 40 is equal to 0, and the line with equation 3x plus y plus k is equal to 0 meet for all values of the constant k. And for this, we are going to say if this means this, going to try and make y the subject here, which will be y is equal to minus k minus 3x, and I'm going to substitute it into this equation so that I get one equation in x squared. So in x, so x minus 3x minus k minus 3x minus 40 is equal to 0. I'm only doing this assuming that these two meet, which we are being asked to show here. So x squared plus 3kx plus 9x squared minus 40 should give us 0. So this is 10x squared plus 3kx minus 40 is equal to 0, like that. So with this now, I'm going to get the discriminant, which is our b squared minus 4ac, because we know that for the 2 to meet, our discriminant should always be greater than 0. So getting the discriminant here, our a is 10, our b is 3k, and our c is minus 40. We'll be saying our b squared 3k squared minus our 4, a is 10, and our c is minus 40, right? That's our discriminant, and it will be 9k squared, and that will give us 40 times 40, which is plus 1600, like this. Now with this, we can see that for any value of k that we put, we are still going to get a discriminant that is greater than 0. First of all, because the value of k will be squared, so if it's negative, it will be positive. So this is always positive, and we also have 1600 being added to that. So if our k is 0, this will be 0, but we'll be adding this. So this shows us that this value or discriminant will always be greater than 0. And if that's true, we know that these two, the curve and the line, will meet. So for this, we say 9k squared is always positive, and 1600 is being added to it. So therefore, for any value of k, the discriminant is always greater than 0. You can use different wording, but the point still remains. If we're getting our discriminant to be greater than 0, then those two should meet, and you do that, you get your 5 marks. Saying the equation of a curve is such that dy dx is equal to 4x minus 3 root x plus 1. Then part A is saying find the x coordinate of the point on the curve at which the gradient is 11 over 2. And so for this one, you're just going to equate this, because we know the first derivative represents the gradient. So equating that, it will give us an equation in x where we get the x coordinate at which the gradient is 11 over 2. So it's 4x minus 3 root x plus 1 is equal to 11 over 2. And multiplying everything by 2, we get 8x minus 6 root x plus 2 being equal to 11. And taking everything to the left hand side, we'll get 8x minus 6 root x minus 9 is equal to 0. And as you can see, the power of this x is half the power of this one, because this is x to the power 1 and this is x to the power half, meaning this is a disguised quadratic. So we can then say let y be equal to, or let's use a different letter here, let b be equal to root x. And as you might know, for a square root, we consider two possibilities or two signs like that, the positive and the negative. But in this case, we're only dealing with the positive, because we weren't told anything about negative square root in the question. So just say let b be equal to that. So this will be 8b squared minus 6b minus 9 is equal to 0. And as you might know, we get two answers from this. I'm just going to use the quadratic formula, but of those two answers, we're only going to take the positive one because we're considering the positive square root there. So that will be 6 plus or minus root of 36 minus 4 or a, and our c minus 9 over 2 or a. So for the two values of b, they will be 6 plus root 6 plus root 36 minus 32 times minus 9 over 2 8, and that's 3 over 2, or for the other value, in the case of getting two positive values, it's minus 3/4. But like I said, we're only taking the positive one. Since we're substituting for a term with a square root, which we know can be positive or negative, we are choosing the positive because we're substituting a positive root here. The question didn't mention anything about having a negative root, so we're discarding this. And we know our b is standing in for a positive root x. So now x to the power 1 over 2 like that is equal to our 3 over 2. And so to get x, we just square both sides so that we get x to the power 1 on the left hand side and 9 over 4 on the right hand side. And that will be the x coordinate of the point on the curve at which the gradient is 11 over 2. The reason why I had to consider the sign was so that we know which one to take between these two, because the question said x coordinate, not x coordinates. So taking this one in would give us 2 x coordinates, which would be correct, but we want 1 coordinate, so we need to consider the sign. Alright, and for part B, says given that the curve passes through the point 4, 11, find the equation of the curve. And for the equation of the curve, we integrate this with respect to x. So that's 4x minus 3 root x, 4x minus 3 root x plus 1. So we're going to integrate this with respect to x. So we get y to b. For integration, we add 1 to the power of x and we divide by the new power, 4x squared over 2. Then this is x to the power half. So we say minus 3x to the power 3 over 2, adding 1 to that, 3 over 2. Then we divide by the new power, and integrating a constant, we get x like that. Then our constant c, and we're just going to substitute this point in here so that we get our c and then our equation. So but first we need to simplify. So our y is 2x squared, then that's minus 6 over 3, which is minus 2x to the power 3 over 2 plus x plus c. Now substituting x with 4 and y with 11, using that point, it's 2, then our 4 squared minus 2, our 4 to the power 3 over 2 plus 4 plus c. So we're just going to simplify this and take it to the left hand side so that we get our value for c. So c would be 11 minus, that's 2, 4 squared plus 2, 4 to the power 3 over 2 plus 4. Oops, it's minus 4 because we're taking it to the other side. And our c is minus 9. And therefore our equation would be y is equal to 2x squared minus 2x to the power 3 over 2 plus x minus 9. And that should be it. Because C1 and C2 have equations. This and this given in expanded form, this given in the normal form that we all know. And it says find the distance between the centers of the circles. So this is like the distance between 2 points. So first we need the coordinates of the centers. And given the expanded form, we know the coefficient of x is 2g, the coefficient of y is 2f, and our center is minus g minus f. So we can just go ahead and say our 2g is equal to 6, therefore g is 3, and our 2f is equal to minus 10, therefore our f is minus 5. So our center will be minus g, which is minus 3, and minus f, which will give us 5. So that's the center for this. For C1 and for C2, we can take it from here. So it's just 9 minus that and minus that, which is minus 4. We say minus this and minus this. Since this is already minus 9, minus that will be 9, a positive 9. And this is a positive 4, so we get a negative. So that's 9 minus 4. And for the distance between point, we're just going to say our minus 3 minus 9 squared plus our 5 plus 4 squared. And this gives us root of minus 2 squared plus 9 squared. Right? So it's root of 144 plus 81, 9 squared. So we get 15. So meaning it's 15 units. The distance between the two centers, it's 15 units, and you get your 4 marks. And it goes on to say P and Q are points on C1 and C2 respectively, and the distance between P and Q is denoted by D. It says find the greatest and least possible values of D. So if we have two centers, two circles, let's assume they're not touching, because if they were touching, the least possible value of D would be 0, because we can say they are touching and our P and Q will be at the same point. So that won't make much sense. And we have a center for this one, so C1, C2. So let's say our P is here, and our Q is here. Let's assume it's a straight line. So this will be P and that will be Q, and we'll be having a straight line passing through the center like that. So this is the center of C1, this is the center of C2, and we know the distance between the two centers, this is 15. This is why I assumed that the straight line would be passing through the center, because in the previous question you were asked to find the distance between the centers, and we can only use that if the line is passing through the center. It's 15, and the radius for C2 we can get it here, because this should be x minus 9 squared plus y plus 4 squared is equal to r squared, like this. But since we have minus 64 here, if we take it to the other side, it becomes positive 64. And that will be our r squared. And our r will be the square root of that, which is 8 for C2. So C2 is a radius of 8. Right? 8, like this. And for the other one, for the C1 equation, we can use, let me change color to black. All right, to get the radius, we can use r is square root of d over 2 squared plus e over 2 squared minus f. And our d, e, and f will be the coefficient of x. This will be d, and this will be e, and this will be f. So our d is 6, e minus 10, f 18. So the radius will be, d is 6, the coefficient of x, so 6 over 2 is square. Then we say plus our e, which is minus 10 squared. So it's minus 10 over 2, because e was minus 10. Then we square, subtract f, which is 18. And this should give us root of, that's 3 squared, 9, plus, that's minus 10 over 2, minus 5 squared, that's 25, minus 18. So r is 4. It's giving us r to be 4. Meaning for this one, it's 4 from the circumference to the radius. And from the circumference to the radius, like this. So the greatest distance will be the whole line, which is our 4 plus 4, or our 4, just this 4 plus 15, plus 15 for center to center, plus 8, and that will be 27. And the least will be this distance. We were saying this 15 minus this 8 and this 4. So it's 15 minus 8 minus 4 to get 3. So the least is 3 and the greatest is 27. Then you get your 3 marks. And for number 8, it is given that beta is an angle between 90 degrees and 180 degrees such that sine beta is equal to a. Then it says express tan squared beta minus 3 sine beta cos beta in terms of a. So for this question, we're going to use this part. Whenever you're given a trigonometric function like this, like sine b or cos or even tan, to be something exact like this, which is a letter or a number, you need to refer to right angled triangles like this. The reason why we're referring to right angled triangles is we get exact values of these when we use this. So if we say this is our beta, like this, and knowing that sine beta is our opposite over our hypotenuse, we'll then say if it's a, we know it's a over 1. So the opposite is a and the hypotenuse is 1. And we know we can also get this side, which we can call x, by using the Pythagoras theorem, which states that 1 squared is equal to a squared plus or x squared. So to get x, we have 1 minus a squared being equal to x squared. And getting x there, we just introduce square root like that. So root of 1 minus a squared is our x, which is this side, the adjacent. Now for the other functions, we're going to say we know sine beta is a from this part of the equation, and our cos beta, using this, cos is adjacent over hypotenuse. Our adjacent is root of 1 minus a squared, and we're saying this over the hypotenuse, which is 1. So just as good as just saying root of 1 minus a squared like that. And for tan beta, we know its opposite, which is our a, over adjacent, which is root 1 minus a squared. So now plugging these into this expression, for tan squared b is the same as saying tan beta squared. So knowing that, we are going to say our a over root 1 minus a squared for this part. Then we say minus our 3 sine beta is a, and our cos beta is root of 1 minus a squared, like this. And simplifying this, we get, for this, we get a squared over 1 minus a squared. And for the other part, it's minus 3a root 1 minus a squared. And that will be our answer for 3 marks. Just confirm, we had a over root of 1 minus a squared for this, and it was being squared, so no need to consider the sign for the square root. It could be plus or minus, but there's really no need to consider the sign there. But for this one, it could be positive or negative. Now, to pick which one we are taking, we go back to this. So for us to have cos being greater than 90, which is from 90 to 180, it should be cos something. For example, this, we're dealing with beta, it should give us a negative. It should be a negative. For us to get values that are greater than 90, our cos should be equal to a negative. And since it's an angle between 90 and 180, it's probably greater than 90. So our cos has to be negative. So considering that, means for this square root, we're considering only the negative, and here as well. And if there's a negative there and a negative here, this sign will be positive. So you just need to be careful there with the signs of your values, especially when the question involves square root signs. Because once you put a positive where you are required to put a negative, the whole trigonometric function becomes wrong, and you get different values from the intended ones. And this will be our final answer for part A. And part B says solve the equation sine squared theta plus 2 cos squared theta minus 4 sine theta plus 3. And as you can see, we have sine theta here, constant there. So we can write this in terms of sine theta using what we know. Now cos squared theta plus sine squared theta is 1. So making sine squared theta the subject, you get sine squared theta being equal to 1 minus cos squared theta. So now rewriting that, we write sine squared theta plus 2 in place of cos squared theta. We write 1 minus sine squared theta, and we say this is equal to 4 sine theta plus 3. Now with this, we say sine squared theta plus 2 minus 2 sine squared theta is equal to 4 sine theta plus 3. Now with this, we get minus sine squared theta plus 2 being equal to 4 sine theta plus 3. And I'm going to take everything to the right hand side to get positive sine squared theta plus 4 sine theta plus 1 is equal to 0. Now with this, we can see that this is a constant, and we have a term in sine theta and a term in sine squared theta. And the power of this sine theta is half of the power of this. And this makes it a disguised quadratic. And by that I mean we can say let x be sine theta, and we'll make a quadratic equation out of this. So this will be x squared plus 4x plus 1 being equal to 0, like that. And for this we can use the quadratic formula. So x will be equal to minus 4 plus or minus root of 16 minus 4. A and c are 1s over 2a, just 2 because it's 2 times 1. And our x will be minus 4 plus root of 16 minus 4, that's 12, root of 12 over 2. We're getting minus 2 plus root 3, which is minus 0,268. And for the other value, we use minus, is minus 3,73. Now we know that x is standing in for sine theta, so we can say sine theta, therefore sine theta is equal to these two values. But when you look at the graph of the sine function, it only goes from minus 1 to 1. It doesn't go down to minus 3, and for that we won't have answers for that, so we discard that and we only take this because it is within this range, right? And so with sine theta is equal to minus 0,268, I would want to use the cast method, where we first ignore the sign. We ignore the sign, so we write it as sine theta is equal to 0,268. And we're doing this so that we can get what we call a PV, which is our principal value, where we just say the sine inverse of 0,268, and we get 15,5. And it is this PV that we'll be using on our cast diagram. And as you know, in the first quadrant we take our answer to be PV, in the second it's 180 minus PV, in the third we have 180 plus PV, in the fourth we have 360 minus PV. And in this A is representing all. We're saying all the trigonometric functions sine, tan and cos are positive. And in the second quadrant where we have S, it's only sine that's positive. In the third it's only tan, which is positive. And the fourth it's only cos. So if we have sine theta being equal to a positive, we're taking answers from the first and second. If it's tan, we're taking answers from the first and third. If it's course which is being said to be positive, we're taking answers from the first and last. And for negatives, we don't take answers from A, and we don't take answers from the trigonometric function that will be required to get an answer for. For example, if it's a sine and it's being said it's equal to a negative, we don't take answers from the second and first. We only consider the third and fourth. So now, having drawn that, we now go back to the original sign, which was a minus. So we're saying our sign is being said to be equal to a minus, so we're only considering the third and the fourth, since sign is positive in the second and the first quadrants. So this is where we use our PV now to say for the third, 180 plus PV, which is 15,5, and for the fourth it's 360 minus 15,5. Then we get our answers to be 195,5 degrees, and 360 minus 15,5, we get 344,5 degrees, and you get your 5 marks for that. And for number 9, says the equation of a curve is y equals that, and part A is saying find the set of values. For these we usually get inequality like terms. So it says find the set of values of x for which y decreases as x increases. Y decreases as x increases. And we can only get a scenario like that when we have negative gradient. And by that I mean, let me try and show that using a line. If we have a line slanting to the left like this, we say it has a negative gradient. If we try and imagine it on a Cartesian plane like this, you can see that as our x values increase from 0 to maybe 1, 2, and 3, our y values are decreasing on this graph, because let me use a different color. Because when x was 0, y was over here, but in x was now 1, y was lower than this, y had decreased. And when x was 2, y was still decreasing up to that value. So you can see that it's only for lines or parts of a curve where the gradient is negative, where we can say y is decreasing as x is increasing. And for that, we're going to try and get the gradient of that, which is dy dx for that. And we're going to say for that dy dx, which values of x do we have it being negative? And it is for that set of values where we have y decreasing as x increases. So now, differentiating that dy dx, if we differentiate a constant, we get a 0, and for 5x we get 5. For the other one, it's plus 12. We take down the power and we subtract 1 from the power of x. Taking down the power there, it's minus 9x squared. This is what we have. So we can write it as minus 9x squared plus 12x plus 5. You can see that it's giving us a quadratic expression like this. So when it's giving us a quadratic expression, we can make use of a sketch. And since we have a negative coefficient of x squared, we know our sketch should be facing downwards. So if we draw a Cartesian plane like this, we can put a sketch, example this, to say this is our y is equal to minus 9x squared plus 12x plus 5. Plus 5. Now with this, for us to say our gradient was negative, we will now be looking at the y-axis, since it's now a curve on its own. So we only have our gradient being negative in the regions below the x-axis, which is this region and this region. So you're saying in those regions, this graph is negative, right? Because if we look at the y-axis, this point is 0 and this will be 1, 2 going up, and this will be in the negative zone. So you're saying below the x-axis, this graph is negative, and we know that that graph is representing dy dx. So we want those regions where dy dx is negative for this to be true. But for us to get that, we need these solutions where this graph cuts the x-axis, and we know it does that when y is 0. So at x-axis y is 0, so we say minus 9x squared plus 12x plus 5 is equal to 0. We equate it to 0 to get these solutions. And with this, we solve it using this minus 45. We can use 15 and minus 3. So it's minus 9x squared plus 15x minus 3x plus 5 is equal to 0. And dividing it by, we can use 3x or minus 3x, we get 3x minus 5, and dividing this by minus 1, we get 3x minus 5. So we get 3x minus 5 and minus 3x minus 1 to be equal to 0. So we say this bracket is equal to 0 or this bracket is equal to 0. So 3x minus 5 being equal to 0, we get our x being equal to 5 over 3. And with minus 3x being equal to, wait, it's minus 3x minus 1 being equal to 0, it's minus 3x being equal to 1, and our x being equal to minus a third, meaning the correct sketch should be looking like this, where we have a negative value and a positive, and the negative one will be minus a third, and the positive one, which is right here, will be 5 over 3. So now, to show the set of values for these shaded regions, we'll be saying x is less than minus a third, and we have x being greater than 5 over 3. So you can write it in set notation to say x is less than minus a third union x being greater than 5 over 3, because that's where we have the graph of our dy dx being less than 0. Alright, and you get your 4 marks for 9 part A. And for part B, says it is given that y equals 9x plus k is a tangent to the curve, meaning it's just a line that touches the curve at a point or at specific points and does not cut through. It says find the value of the constant k. So for us to get k, we are going to try and equate this to the equation of the curve, which is y is equal to 4 plus 5x, 4 plus 5x plus 6x squared minus 3x to the power 3, if I'm not mistaken. Yes. We're going to refer to this curve when we substitute the one of the coordinates. I don't know which one we're going to get first. One of the coordinates could be x or y of the point where they meet, because we know if we have a curve and a tangent, they meet at a point, like this, so they share a point. So we're going to try and use that. That's why I wrote it down here. But looking at this, we can see it's in the form y equals mx plus c. So we already have our m. So for that line, our m, which is gradient, is 9. And we know at this point, the gradient of a straight line is the same at any point of the line, even the point where it meets the curve, meaning at that point, which we can call maybe b, at that point the gradient of the curve is also 9. So to get the x value of that point, we can plug in this and equate it to the gradient of the curve, which we got to be 5 plus 12x minus 9x squared. 5 plus 12x minus 9x squared. 5 plus 12x minus 9x squared, like that. And we say this should give us 9, right, at that point b there. So taking everything to the right hand side, we have 9x squared minus 12x, then 9 minus 5, which is plus 4, like that. And to get the x coordinate, where we have the gradient as 9, we're going to use the quadratic formula. So x give us minus b, which is 12, plus or minus b squared, that's 12 squared minus 4. A is 9, or c it's 4, or over 2a, which is 2 times 9, 18. And this is going to give us 12 plus root of 12 squared, 144, minus 16 times 9 over 18. And that is giving us 2/3. And it looks like we have another value. It's 2/3. We're not getting two answers, we're only getting 2/3. So the x value of that point is 2/3. The x value of this point, which we called b, is 2/3, and we have a y value there. So with this, to get the y value, you know the y value, this point is being shared by the line and the curve. So if we substitute this into the original equation of the curve, we'll get the corresponding y value, which will be this y coordinate, right? And after that, we substitute it into the line to get k, because we know the x value. So substituting it into the equation, there we get 4 plus 5, or 2/3, plus 6, 2 over 3 being squared, minus 3, 2 over 3 being cubed. We're getting it as y is equal to 9 and 1 over 9, like this. So now we're going to substitute it into the equation of the line. So 9 and 1 over 9 is equal to 9x plus k. But we know at that point our x is 2/3. So we can substitute 2/3 for x there to get k. So it will be 9 and 1 over 9 minus, this is 3. So it's to be minus 6, to be 3 and 1 over 9 for k. And that will be the value of k for 4 marks for number 9, part B. And for number 10, saying an arithmetic progression is first term 5 in AP, is first term 5, and a common difference d. So write d equals d. Let's just use uppercase for this one so that it makes sense. D is equal to d. Then says where d is greater than 0, so I'm not taking negative values for d. And it says the second, 5th, and 11th term of the arithmetic progression in that order are the first 3 terms of a geometric progression. And it says find the value of d. So in trying to comprehend the information that we're given here, we know for the second term in an arithmetic progression, or any nth term, not any term, but we can say any term in an arithmetic progression, you say a plus n minus 1 d. So if it's the first term, we say a plus n will be 1, so it will be 1 minus 1, which is 0 d. That's why a is our first. And for the second, we'll be saying a plus or 2 minus 1 d. So just a plus d. I'm going to use that. So our a is equal to 5. Then our second term will be a plus d. As you can see, a plus d. And you know a is 5, so it will be 5 plus d. And for the fifth term, it will be a plus 5 minus 1 d. So it will be 5 for a plus 4d, like this. And for the 11th, it will be a, which is 5, plus 11 minus 1d, which is our 10d. And we're told that these are the first three terms. So this is the first term of a geometric progression, the second, and this is the third, like this. And it says find the value of d. And we know that if they say we're not dealing with a geometric progression, we have a common ratio which is constant. So if we say the second term, which is our 5 plus 4d, over the first term 5 plus d, it gives us the same ratio as saying 5, which is the third, 5 plus 10d, the third term, over the second term 5 plus 4d, like this. And so with this, we can cross multiply and get d. So in cross multiply and get 5 plus 4d squared being equal to 5 plus d and 5 plus 10d, like this. And squaring that, we get 25 plus 40d plus 16d squared being equal to 25, and that will be 50d plus 5d, so it will be plus 55d, then plus 10d squared. And we have 25 on both sides of the equal sign, so we can cancel it out. And taking everything to the right hand side, we get 10d squared, and 55d minus 40d, that will give us plus 15d. And we have minus 16d squared. I hadn't noticed that. So this will be minus 6d squared plus 15d equal to 0, like that. And we factor out d, so minus 6d plus 15 should give us 0. So for the first value, d is equal to 0, or we say minus 6d plus 15 is equal to 0. And for this part, we get d to be 15 over positive 6, because we would have taken minus 60 to the other side. And since the equation says d is greater than 0, we will only consider this d to be 15 over 6. And that will be it for A. And for part B, it says the sum of the first 77 terms of the arithmetic progression is denoted by S77. The sum of the first 10 terms of the geometric progression is denoted by G10. Then it says find the value of S77 and minus G10. Referring to the formula that we're given in our formula booklet, which says Sn is equal to n over 2 bracket 2a plus n minus 1 d. We're going to say if we are having sum of the first 77 terms, means this n is 77, so S77 will be 77 over 2, then our 2a plus our 77 minus 1, which is 76 d, like that. And for the G10 is the sum of the first 10 terms of the geometric progression. We're going to use the formula which says a1 minus r to the power n over, so it's the sum of 10, which is our G10, over 1 minus r, like that. And we're being asked to get the value of S77, which is this minus this. And as you can see, for this we have everything that we need. 77 over 2 bracket 2a, which is 2 times 5, which is 10, plus 76 multiplying d 15 over 6. We can just say 5 over 2. If we divide by 3, get 5 over 2 and use it as it is, 15 over 6, like that, and we'll get 77 over 2, 10 plus 76, 15 over 6, and that will be 7,700 for S77. And for this one, for the value of A, the value of A is this one. It's 5 plus D. The value of it's A, because we're not dealing with the geometric progression. So it's 5 plus D, which is 15 over 6. This is A value. 5 plus 15 over 6, which is our 7.5 for that. And for the R value, we just pick any of these using the D value that we got. So 5 plus 4D, 15 over 6, over 5 plus 15 over 6. And that should give us our R. 5 plus 4, 15 over 6, over 5 plus 15 over 6. And that is giving us 2 to be our R. So substituting those values, we have 7,5, 1 minus our 2 to the power n is 10, over our 1 minus 2. And that gives us 7,5, 1 minus 2 to the power 10, over 1 minus 2, which is minus 1. And that is giving us 7,672,5. So now this, did we get 770? Or there is, let me just check. 77 over 2, 10 plus 76, 15 over 6, Yes, it was 7,700. So now saying 7,700 minus 7,672.5, and this is giving us 27 and a half, and we get our 5 marks for that. And for number 11, which is the last question, says the function f is defined by f of x being equal to 3 plus 6x minus 2x squared, where x is an element of a set of real numbers. And for part A, it says express f of x in the form a minus b bracket x minus c squared, where a, b, and c are constants, and state the range of f. So this is just us expressing it in its completed square form. So we can write this as minus 2x squared plus 6x plus 3, and we factor out minus 2 by introducing square brackets there. We get x squared, then that divided by 2, we get minus 3x, and this will be minus 3 over 2, like that. And then we complete the square for this part, which is inside the square brackets, which will give us x minus 3 over 2 squared minus 3 over 2 minus this squared. So we have 3 over 2 being squared, 3 over 2 being squared, which is our 9 over 4, like this. So these are square brackets, and so we get minus 2 or x minus 3 over 2 squared, then our minus 3 over 2 minus 9 over 4 will give us minus 15 over 4, like this. And so multiplying everything by that minus 2, get minus 2x minus 3 over 2 squared, then that will give us plus 15 over 2. And rewriting this, we get 15 over 2 minus 2x minus 3 over 2 squared, which is in the required form. And we get our 3 marks for 11 part A. And for part B, which is saying, and for the range, for us to get the range here, you can see that we have this value. So let's take the coordinate of the turning point. It's minus this, which is 3 over 2, then our 15 over 2, like that. So sketching it there, you can see that there is a negative coefficient of x squared, meaning it's facing down like this, with the turning point at 3 over 2 and 15 over 2. And you can see that the graph only goes as far as 15 over 2 in the y-axis, 15 over 2 and below. So you can see that f is less than 15 over 2. You can say less than or equal to 15 over 2, since it only goes as far as 15 over 2 in the y-axis. And if you look at this, you have 15 over 2 here, and you're subtracting this for any value of x. You're always subtracting that part, so you're always going to get values that are equal to 15 over 2 or less. So that's why we say the range is less than or equal to or 15 over 2 there. You get your full marks. For part B, it's saying the graph of y equals f of x is transformed to the graph of y equals h of x by reflection in one of the x's followed by a translation. Then it says it is given that the graph of y equals h of x has a minimum point at the origin, and it says give details of the reflection and the translation involved. And so if we're having a graph with a minimum point at the origin, it will be looking like this, right? So h of x has a minimum point at the origin, and if you look at this part, we said that is the general sketch of that equation. As you can see, it's facing up, it's facing down, and this one is facing up now, meaning the reflection was in the x-axis. To say the original was facing down, and when it was reflected in the x-axis, we had h of x, which is facing up with the minimum point at the origin, like that. So we can say the reflection was in the x-axis, and for the translation, the minimum point, we know the minimum point of this was at the maximum point, rather it was at 3/2 and 15/2, like this. And for us to get 0, 0, we would have translated this by a factor minus 3/2 and 15/2, like this. So that we say we subtract these from this point. So say on the x-axis we're subtracting, and on the y-axis you also subtract. And we also need to understand that we're not subtracting from this point, but rather we're saying, let me just restart this. If we have a Cartesian plane like this and an original graph like that with a turning point at 3/2 and 15/2, like this, if we reflect it in the x-axis, we'll get something like this, right? And with that, you can see there is now a minimum point at that point. Now with that minimum point, we're not necessarily saying, let me just try and be accurate with this one. With something like this, and the minimum point, now we have the coordinate 3/2 for the x, they share the same coordinate, but now the y coordinate will be minus 15/2, like this. And after that, because we know this is now our h of x, this is now h of x, it's going to be translated, so it's going to be moved either this way until it gets to this point where the minimum point is the origin. And for us to do that, as you can see, we move this much to the left of the x-axis, which is just us subtracting this. So it's minus 3/2, meaning we're moving towards the left. Then we move up this much, which is this, because it's minus 15/2, so we're now moving that up. So write it as a positive 15/2, like that. That's why I said is a reflection in the x-axis, and the translation is by a vector minus 3/2 and 15/2, and you get your 2 marks for that. And part C says the the function g of x is defined by that. Just check to see if we 3 plus 6x minus 2x squared. Yes, that's the expression we used. Defined by g of x, which is equal to 3 plus 6x minus 2x squared, where x is less than or equal to 0. And it says sketch the graph of y equals g of x and explain why g is a 1-to-1 function. You're not required to find the coordinates of any intersections with the x's. So we have this in its complete square form. It's 15 over 2 minus 2, then that was x minus 3 over 2, x minus 3 over 2 squared. It's the same as this. And for us to be able to sketch that, we can see we have a negative coefficient of x squared there, meaning on our Cartesian plane, g of x will be facing downwards because it is a negative coefficient of x squared, and while it's facing downwards, it has a turning point at 3 over 2 and 15 over 2. So it's like this. Let me just make sure it crosses the y-axis because we're going to need to talk about this. The domain says for x being less than or equal to 0. So when x is less than 0, it's this region from the y-axis, which is our x equals to 0, going this way. And if we use our horizontal line test for this part of the curve, because that's the only part where we have x being less than 0, using the horizontal line test where we draw horizontal lines, we can see that for all horizontal lines that we draw that cut this part of the curve, there is only one corresponding x value for that. So for this one, it will be somewhere there, and for that, and that means it is 1-to-1. So we have sketched, and in our explanation we say for all horizontal lines that cut the part of the graph in the region where x is less than 0, there is only one corresponding x value. So that for each one of the y values, there is one corresponding x values, meaning it's 1-to-1. And you get other 2 marks for that. And part D, which is the last part of the last question, says sketch the graph of y of the inverse of g to x on your diagram in C and find an expression for that, for the inverse, and you should label the 2 graphs on the diagram appropriately and show any relevant mirror lines. So the graph of a function, or the graph of an inverse of a function, is just a reflection of the graph of the original function in the line y equals x, meaning the line y equals x will be the mirror line. So with this, the line y equals x will be running through this, passes through the origin like that. And so let me try and show it this way instead. Our y, our x, our origin. It says this is our 3 over 2, 15 over 2. This point, let's move it higher a bit. So if it's here, I want to make sure that it's crossing this part like this. That makes more sense other than making it only cross the x-axis on its positive side. So we have this now, and we were told initially to sketch that for x being less than or equal to 0, meaning even for the diagram that I just rubbed off, we only needed this part, so this would have been 3/2 or 15/2, like that, and the graph would have proceeded like this. But we are not concerned about this dotted part, only concerned about this part where x is less than 0, like that. We're not drawing the entire curve. And if we put in our y equals x, which is our mirror line, we can then draw or sketch the graph of the inverse like this. And as you can see, it's a reflection of the original one in the line y equals x. So then this will be the inverse, and that will be the original g of x. So this is the correct diagram. I had missed this when I was sketching, and for part D, where it says sketch, we have sketched. Then we're only left with getting the expression for the inverse, and for that we're going to need the expression for the original function, but I would prefer to use the one which is in this completed square form, 15/2 minus 2x minus 3/2 squared minus 3/2 squared, and we know this is our g of x. So we take our g of x to be y, so 15/2 minus 2x minus 3/2 squared is equal to y. Then you swap the y for x, and we make the new y the subject of formula. So this is 15/2 minus 2x minus 3/2 squared. So for the x, we are swapping it for y, and for the y for x, like this. Then we try and make this y the subject, and the resulting expression that we get would be the expression for the inverse. So we get x minus 15/2, then that divided by minus 2 being equal to y minus 3/2 squared, like that. And to get rid of this, we square root both sides, and now we have root of x minus 15/2 over minus 2 being equal to y minus 3/2. And taking this minus 3/2 to the other side, we have 3/2, it's now positive, plus or minus root of x minus 15/2, which you can simplify, being equal to y. And this will be the expression for the inverse. Let me just rewrite it here, plus or minus root of x minus 15/2 over minus 2 being equal to the inverse, like that. But we can't take it with two signs in the middle here, we have to pick one. And for us to know which sign to pick, we just look at the domain of the original function. And for part C here, we're given the domain to be x less than or equal to 0. We know the domain of the original is the range of the inverse. So the range of our inverse should be less than or equal to 0. So g of x, like the inverse of x, should be less than or equal to 0. The domain of the original is equal to the range of the inverse. So the range should be something that is less than or equal to 0. And for us to get something that is less than 0, we cannot be adding, because this part is always going to give us a positive. So if we add, it will be 3 over 2 plus that part. But if we subtract, we have a chance of getting 3 over 2 for this, and that will be 0, or something that is more than 3 over 2, which will obviously give us a range that is a value that is below 3 over 2 or 0 itself. So take minus. Or one other way that you can interpret it, if you have less than or equal to, you go for the negative sign. If you have greater than or equal to, you go for the positive sign. So for this, we are saying our final answer is 3 over 2 minus root of x minus 15 over 2 over minus 2, like that. And you can simplify this, but that will be our final answer. And that brings us to the end of this question paper. I hope you were following through.